This is part 6, question 21. The table below lists a random sample of 41 speeding tickets on I-25 in Colorado. Find the following probability, and notice here we have some directions. We're going to round to 4 decimals accuracy, and we're not going to put any fractions here. If a random ticket was selected, what would be the probability that the driver was a female? Now, the probability that the driver was a female is how many females out of the total. So I have 15 females out of the total of 41 females. So the first probability is basically 15 females out of 41. Again, the answer, I have to turn it into decimal first. So 15 divided by 41. And then I have to round it to 4 decimal places. I'm going to copy and paste. So the first one, the second one, given that a particular ticket had a male offender, what is the probability that they were more than 20 miles per hour over the limit? Here that the given category is a male. So we're only going to focus on only the table or the row that has the male, sorry. So this is the category we're going to focus on. I'm not going to look anywhere else. What is the probability that they were more than 20 miles per hour over limit? How many males are 20 miles over limit? Miles per hour over limit? That is 12 of them. So the answer for this one is going to be 12 out of how many males in total? That is 26, because of that given, which is a conditional probability. So I'm going to answer that question here, 12 divided by 26. And that is going to give me this number. I have to round that number to 4 decimals and then copy and paste it. The next question, given that a particular ticket was 10 to 20 miles per hour over limit, what is the probability that the driver was a female? So the given category here is basically they are 10 to 20 miles per hour over limit. So I'm just going to look at this category. I'm going to forget about everything else because that is the condition, the given condition to me. What is the probability that the driver was a female? How many females are in that category? I have 9 females in that category out of 17 in total of people who are going 10 to 20 miles per hour over limit. So here again, I'm going to say this is equal to 9 divided by 17. Which is this number. I'm going to copy and paste it. I don't think the question is going to reject it just because it's not rounded. If a random ticket was selected, what would be the probability that the driver was a male? So, how many males are in this survey? I have 26 males in this survey. So 26 out of how many in total? 41. So I'm going to say here 26 divided by 41, and that is the answer. I'm just going to copy and paste it. The next question, if a random ticket was selected, what would be the probability that the driver is a female and driving 10 to 20 miles per hour over the limit? So since this is an and event, I need to find the number that satisfies both categories. So the categories are female and drive 10 to 20 miles per hour over limit. So how many females drive 10 to 20 miles per hour over limit? That is 9 females. So 9 females out of the total of 41. 9 out of 41. There's the answer. And then the last one, if a random ticket was selected, what would be the probability that the driver is a female or driving 0 to 10 miles over the limit? Or event means we're going to combine both of these categories with a repetition. So the categories are first female, and the second category is they drive 0 to 10 miles per hour over limit. So if I highlight all of both of these categories, all of the numbers in these categories, first of all, I'm going to highlight all of the females. So here is the females. I'm not going to highlight the total. And then the category of 0 to 10 miles, that is 6 and 1. So in this case, if I added all of these numbers together, I'm going to get the event female or driving 10 to 20 miles per hour over limit, because I have all of the females that is 15 females, and then I need to look at, or means addition, I need to look at the second category, which is driving 0 to 10 miles per hour. Sorry, this is 15 plus, and then driving 0 to 10 miles per hour. I'm going to count how many people in that category, avoiding the females, and I end up with only counting 6. So 15 plus 6 is going to be 21. So the answer for this one is 21 out of the 41. And then I'm going to compute it right here, 21 out of 41, and that is the answer. The next question, another probability question. I have a table that summarizes some information, and I want to find the probability that someone is from the US. So someone is from the US is the probability, if you select somebody, what is the probability that someone that you selected is from the US? That is how many people are from the US, which is 44, out of the total of the people in the survey, which is 87. The next one, what is the probability that someone has at least 2 children? So at least 2 children, that means all of the people who have 2 children or more than 2 children. That is 18 plus 17 out of the total, which is 35 divided by 87. What is the probability that someone is from the US and has 1 child? So when it's an AND event, I have to find the number that satisfies both of these categories at the same time. So I'm looking for all of the people in this survey who are from the US and has 1 child. So how many people are there? That is exactly 16 people out of the 87. What is the probability that someone is from the US or has 0 children? So in the OR category, I have to combine all of the people in both of these categories without repetition. How many people are from the US? I have 44 people. How many people has 0 children who are not from the US? That is 20. So 20 plus 44 is 64 out of 87. Given that the person is from the US, what is the probability that they have 3 or more children? So we're only going to focus on the first row that represents all of the people from the US, because that is a given condition. And we want to find the probability that the person from that category has 3 or more children. That is 8 people who satisfy that condition out of the total of 44 people. So 8 out of 44. And then the last one, given that the person has 1 child, so we're only going to focus on the category of 1 child. That is basically this column right here, the column that has 1 at the top, which has 16 people from the US and then 11 people outside of the US. So that is how many people are from the US in that category. I have 16 people out of the total of 27 people in that specific category. And that should be the answer for the last part. Question number 23 is another probability question. It's similar to the previous one. I have a table that summarizes 56 people into specific categories. If a random person was selected, what would be the probability that the person was not a Broncos fan? How many people here are not Broncos fan? I have 16 people. They're not Broncos fan out of 56 people in total. So that is the answer for the first question. Given that the person is Broncos fan, so I'm just going to focus on the first row in the table here. I'm not going to focus on anything else. What is the probability that they have 6 or more siblings? So how many people in that category that I just highlighted have 6 or more siblings? I have 13 people out of the 40 people that I focused on. I focus on that because it's given. That is a condition. I have to focus only on that one. Given that the person has 3 to 5 siblings, what is the probability that the person is not a Broncos fan? So in this case, I'm just going to focus on the category here, the category 3 to 5 categories, this column only, which is basically the second column. not counting the labels here, the second column in the table. So how many people there are not Broncos fan? I have 7 people out of the 25 people in that category. So 7 out of the 25 people are in that category. If a random person was selected, what would be the probability that the person was a Broncos fan? How many Broncos fan do I have here? I have 40 Broncos fan out of the 56 people in the survey. If a random person was selected, what would be the probability that the person is not Broncos fan and has 3 to 5 siblings? And event means I need to find one number that satisfies both of these categories. So not Broncos fan and have 3 to 5 siblings, that is basically number 7. So I have 7 people out of the 56 who are both Broncos fan and have 3 to 5 siblings. The next one, if a random person was selected, what would be the probability that the person is not Broncos fan or has 0 to 2 siblings? So or event, I need to combine both categories. I'm going to count how many Broncos fan there is, and then I'm going to count how many people have 0 to 2 siblings, and I'm not going to compute the Broncos fan twice. So let me look here. I have 40 Broncos fans, and then the people who have 0 to 2 siblings are basically 9 Broncos fan and 4 not Broncos fan. The 9, I counted that with the 40 already. So I'm just going to add the 4 people who are not Broncos fan to the group, and that should combine all of the people who are either Broncos fan or have 0 to 2 siblings without repeating the 9 people who are both Broncos fan and have 0 to 2 siblings. So 40 plus 4 in this case is 44 out of the 56. So 44 out of 56. Not Broncos fan, sorry. It's not Broncos fan. I was reading it Broncos fan. How many people are not Broncos fan? I have 16 people who are not Broncos fan. And then how many have 0 to 2 siblings that they are actually Broncos fan, because I don't want to count the 4 twice. So that is only 9 people. So 9 people plus 16 is 25 out of the 56. So that is 25 out of the 56. Last one, if a random person was selected, what would be the probability that the person was a Broncos fan and has 3 to 5 siblings? Again, and event means I need the number that satisfies both categories. So the number that satisfies both Broncos fan and have 3 to 5 siblings that's Broncos fan, have 3 to 5 siblings, is the number 18. That is 18 out of 56 people. And that should answer the last question. The next question is basically this is a discrete random variable or discrete probability. And to answer the question, the first question, find the probability that exactly 5 Mexican Americans among the 12 jurors. I have the table here. I have this habit of not reading the question because I know what's going on in the question, so don't fall for that habit. Please read each question thoroughly and try to understand what's going on. So I'm going to copy this table and I will paste it into an Excel, and then we'll answer the rest of the questions. So for this question, what I did here, I copied it and I pasted the table into an Excel sheet, and then I answered this question. So the probability that exactly 5 Mexican Americans among the 12 jurors, that is the number in front of 5. And then find the probability of 5 or fewer Mexican Americans among the 12 jurors. Basically what I did, I went to the table here and I added all of these probabilities from 0 to 5, all of these probabilities, and that was the answer. So I copied and pasted the answer right here. To answer the last part, does 5 Mexican Americans among 12 jurors suggest that the selection process discriminates against Mexican Americans? So if you look at the probabilities here, you see that this probability is less than 5%. So if it's less than 5%, you're going to say yes, it discriminates against Mexican Americans. If it's more than 5%, then you're going to say no, it doesn't discriminate against Mexican Americans. The next question is a discrete probability distribution as well. So the first step I do is to copy the table and head to an Excel sheet and paste it over there. So I'm just going to do another one. And then the first question says, what is the probability of selling 15 cheesecakes in a given day? 15 cheesecakes is not here, but I know because this is a probability distribution that if I added all of these probabilities, the answer is going to be 1. So if I take 1 and subtract all of the rest of the probabilities from it, I will end up with the right answer under 15. So first of all, I'm going to find the sum. Auto sum. So the sum is 0.19, and I'm sure it didn't add everything up because it only clicked on the one cell in front of it. So the answer is 0.91. Now to find the missing answer, I'm going to say 1 minus 0.91, the sum of the other ones, and the answer is 0.09. So I'm just going to copy that and paste it over here. So this is the first answer. The second answer is, what is the probability of selling at least 10 cheesecakes? At least 10 cheesecakes. At least 10 cheesecakes means 10 or more. That means 10 or more, 10 or 15 or 20. The answer is 0.31. The next one, what is the probability of selling 5 or 15? 5 or 15 means either 5 or 15, and that is basically adding these probabilities up together. 5 or 15. I added 5 for 10. So add 5 and 15. 5 plus 15. 5 or 15 means 5 plus 15. And that is 50%. What is the probability of selling 25 cheesecakes? I don't have 25 cheesecakes here, so the probability is 0. Give the expected number of cheesecakes sold in a day using the discrete probability distribution. We know that the expected value is the mean, and the mean is basically you multiply the number of cheesecakes sold by the probability and then find the answer, which is you can easily find it using the sum product function. So sum product is going to ask you for the arrays that you want to multiply together. I'm going to select the first row for the first array and the second row for the second array. What this does, it's going to multiply the corresponding numbers and then add them together. So the answer is 7.5. So the answer here is 7.5. On the long run, we expect the shop here to sell 7.5 cheesecakes per day. And then the last part, what is the probability of selling at most 10 cheesecakes? That is basically either 10 or less. That is basically the sum of 10 or less because it says at most 10. So 0.72 is the answer. 72 is the answer for the last one. Number 26 and the last question is basically giving us a probability distribution table, which is discrete, and we want to find the following answers. So use the random variable notation to express symbolically each of the following. The probability of an event in which the number of busy lines is exactly 4 is equal to 0.15. So probability means P of, and then event means X, and then exactly means equals to 4, and then equals to 0.15. So P of X equals 4 equals to 0.15 is this one. The probability of an event, so probability of X is exactly 4 equals 4. So P of X equals 4. And the last one, an event means X. The event is X, in which the number of busy lines is exactly 5. That is X is equal to 5. So this is the last option here. Use the above probability distribution table to find the following. We want to find the probability that X is greater than 3. That means it's strictly greater than 3 and less than or equal to 4. That is the probability of 4 only because the 3 is not included. So 0.15 is the answer for that one. If your question shows same numbers, so let's say this number was 3 and this number was 3, then try to find another version of the question because it's not going to work. So here, what is the probability that X is equal to 2 or X is equal to 3? That is adding the probability of 2 plus the probability of 3, which is equal to 0.54. And the last one, what is the probability that X is greater than 1? That is everything above 1, greater than or equal to 1, including 1. That means we're going to add all of these probabilities together. Or you could say it's 1 minus the one that we didn't add, which is 0.02. That gives us 0.98. Thank you for watching. I'll see you in class.